So, null pointer exception. Sweet. So, before we talk about the null pointer exception, or actually, as part of talking about the null pointer exception, does anyone notice anything that looks very, very wrong? Take a look at where I print things out. I print things out when I first create the linked list. That's when it prints out null. I print out the linked list after I add a bunch of things to it. That's here. And then the next time I print things out is here, line 14, and it prints this out. After which it immediately crashes on this line. So it successfully removes 12, I assume. 12 is not in the list, so there's nothing to remove. And it successfully removes 42 and a bunch of other things. Right? It starts out 4, 17, 23, 42, 6, 9. And that's correct. After I remove 42, it becomes 4, 6, 9, which is very much not correct. If we look back up at what we do for, let's make that a little smaller. If we look at what we do for remove, we know it's not here. Head does not equal null. And it's not the first element that we're trying to remove, though we should probably test that as well and make sure we don't do anything stupid. So it must be somewhere down here. And if we look at what we're doing, we notice that last gets set to head and never gets set to anything else, which is not what we intended to do. Last is supposed to point to the previous element, the previous link. But that never happens. So, and the problem is that we only advance cur, we never advance last. So if we advance last, that should fix things. That also brings up an issue, or something to note, which is in Git, we kind of assume that the index is in the list. We don't really ensure that the specified index is within our range of valid indices, which is probably something that we should do. So I will check to see if index is less than size. If index is greater than or equal to size, what should we do here? In theory, we should probably blow up, but throw new index, array index out of bounds exception. Array index out of bounds exception. What am I missing? Cannot find symbol size. Yes, that's a good point. So let's implement that method. If head equals null, return 0.
basically the same thing as we've done in all the other methods. We want to iterate through all the elements that we have, starting at the beginning and going until we hit a null. And here we should increment size and then advance cur. And now let's make sure we're counting the right thing. So using this example on the board, if we start out with cur pointing to head, cur is not null, size is 0, we increment size, and we move on to the next one. Cur is still not null, so we increment size and move on to the next one. So now size is 2, and we're pointing to the third element. Increment size, it's not null, so increment size and move on to the next one. It's 3. It's still not null. Increment size and move on to the next one. It's 4. And now it is null. We break out size is still 4, and that is accurate. This thing on the board has 4 elements. And it turns out that this will actually cover this special case, so we don't need that. Because if head is null, cur will be set to null. The while will check if cur is not equal to null. Cur is equal to null. It will not execute the loop any number of times, so size will still be 0. And then we can, at the very end, return size. Return size. There we go. So let's compile it. Let's run it. Try again. And hopefully it's a little more successful this time. So we print out the linked list with nothing in it, so it prints out null. We add some stuff to the linked list. Print it out again. And that's what we get. It looks like our remove method is still not working properly, but given that this linked list has the elements 4, 17, 23, 42, 6, 9, this would be the element with index 4, so ll.get4 should in fact return 6. It does. ll.contains 9, it does contain 9. Index of 23 is the index 2. So all of our tests succeeded. They gave us what we were expecting, except for after the removal of 42. So let's go ahead and see what's not happening in our remove method. Let's see, remove. So like I said before, we know this is not what's happening. Also, this is not what's happening. So our first iteration of this last points to the first element, the same as head, and cur points to the next one. Cur is not null rather. Cur is also, let's change the numbers here so that it actually reflects what we're dealing with. I wonder if there are actually some. No, of course not. Can someone read off the numbers to me that I'm using? Okay, thank you. Okay, so this is head. And I'm going to use my left hand to point to last, and my right hand to point to cur. So, lines 34 and 35, last points to the same thing as head. Cur points to heads next. Okay. Cur does not equal null. Okay, cur does not equal null. Cur.data equal k. No. So now we increment, or we advance last to equal cur.next. That doesn't make sense. Which hand is it? Last is head. Last equals cur.next. No. No, that doesn't make sense at all. That's what we want. Right? So now last equals cur. Cur equals cur.next. And we do the same thing. 23 is not 42. Advance, advance. 42, yes, so then we should change that. I think that should work. Last, we could also set last to last.next, just to be confusing. Bless you. Yeah, of course it doesn't. There we go. That looks better. Any questions? A lot of this is kind of reason through the process and figure out what things should do. You can copy things straight out of the book, but that's really no fun. What I like to do is take the concepts in the book and then try to implement them myself, and then look back at the book to see if I got everything right. I also imagine it's more fulfilling for you for me to not just read right out of the book. Regurgitate the code directly onto the screen. So that's pretty much linked lists. Doubly linked lists we can implement in essentially the same way. We just need to be careful of another set of references, making sure that when we add and remove things, we change the previous pointer as well as the next pointer. So now let's look at the next homework. So homework 1 is due tonight at 11:59. Homework 2 is technically assigned today and is due a week from today again at 11:59. So assignment 2. The basic assignment is take the instruction objects that you created in assignment 1 and store them in a linked list. Basically taking the int linked list that's implemented in the book and I implemented on the screen here, and change it so that it uses instructions instead of ints. I also want this linked list to implement the iterable and iterator interfaces like we did in last class. I didn't do it with this linked list, but the process should be essentially the same. In fact, a lot of what we did is just iterating through from node to node. What else? Right, we're going to call this linked list program, because a program is a series of instructions, or other way around. A series of instructions is a program. Private nested class, just like I implemented in the video, though it will have a slightly different name. And methods that do exactly the same things as some of the methods I implemented in class. Questions? I will post both of these files. So, if there aren't any other questions, you're welcome to start working on the homework. You're welcome to try implementing a linked list on your own. There are also some programming projects starting on page 248 that might be interesting, give you a little more practice with linked lists.